Welcome to Math with Mr. P. Today we're doing 7th grade math. This is Chapter 2, Lesson 5, and we're dealing with percent of change. We're going to have quite the amount of vocabulary words today. We have percent of change, percent of increase, percent of decrease, and percent error. So it's going to be very important that you guys have your notes ready to go, as we are going to need to define every single one of those terms and then understand the process of finding those terms. So let's start with the real world link here. The Indy 500 is one of the world's great motor races. The table shows the average speed of winning race cars for various years. So in 1922, 94 miles per hour. In 1955, we have 128, and in 2010, 162. Write the ratio. Speed increased from 92 to 95. So how much changed from 92 to 95? So basically we need to find the difference between 94 to 128. We would do that. We're going to bust out a calculator here. We need to do 128 minus 94. We're finding the difference. So what changed between the two? And that's a difference of 34 miles per hour. So I'm going to get my pen ready. So speed increase, speed in 1922. And speed in 1922 was 94. So we're going to put 33. I believe it was 33 or 34. It was 34. It was an increase of 34. We're going to get the calculator and we're going to check this one last time because I closed it without writing it down. 128 minus 94 should give us 34. It did. So I have a ratio of 34 over 94. This is going to be my ratio. We're going to round to the nearest whole percent and find out how much the percentage changed. So again, 34 divided by 94 will give me 3617. Remember, to solve a decimal into a percentage, we jump the decimal twice over to the right. So this will make 36.17. So it's actually going to be closer to 36. So 36%. Write the ratio. Speed increase from 1955 to 2010. So we're going to grab our calculator again. We're going to clear it. So it was 162 in 2010 minus the 128 in 1955. That's a speed increase of 34 miles per hour as well. Let me just double check that I did that correctly. 162 minus 128. We did it correctly. 34 divided by 128 now will give me 0.265. The decimal will jump twice to the right, which will make 26. 26.5 will actually have to round up to 27. So that is an increase of 27%. Therefore, there was a bigger jump percentage-wise from 1922 to 1955, where it went up 36%. However, it only went up 34 miles an hour. And here it also went up 34 miles an hour, but here it was 27% of an increase, even though it was the exact same amount of miles per hour that it went up. Why are the amounts of increase the same, but the percents different? So remember, when you come up with a different number, a percentage of that number will change. So for example, think of it like a quiz. So there are 5 questions on the quiz. That means every question is worth 1/5 of your grade. And if I take 1 divided by 5, that means every single one, and I jump it twice to the right, every question is worth 20% of your grade on that quiz, test, whatever, if there's only 5 questions. Typically, there would be 20 questions on a test quiz, which means every question is going to be 1/20th of your grade. 1 divided by 20 will give me 0.05, and if I jump that twice to the right, that means every question is worth 5% instead of 20%. Now remember, the speed increased, which changes the percentage, because when we take 94 to 28, we're looking at 94 being our baseline. So an increase from 94 to 28 was 30 whatever percent we said earlier. So let me do that again. That was 34. I erased it too soon. Actually, you know what? Undo. There we go. So that is 36%. From 94 to 128 was a 36% increase, even though it went up by 34 miles an hour. Now, if I jump from 128 to 126 and still only add 34, I can't expect the same amount in percentage. 34 is not 36% of 128 like it was of 94. So now 34 is only 27% of that number. It will change the more you add to it. The same thing with the tests and quizzes here. 5 questions means every single question is worth 20%, versus having 20 questions on the test or quiz. Now every single one's percentage lower since there's more of them. So the more you add to it, the less the percent becomes, because you're getting a bigger baseline number, if that makes sense. And we're going to erase this. And we're going to talk about percent of change. Percent of change is a ratio that compares the change in quantity to the original amount. So what we did here was we checked. We said in 1922, the average speed was what, 94 miles an hour? Or the high speed was 94. And then 1955, it was 128. When we took the difference between the two, we realized that it was an increase of 34. So the change is the numerator. The original one, or the one that came before 1922, was 94. So this is how we wrote our ratio. When we divided 34 by 94, we ended up rounding it to about 36%. 34 divided by 94 gave us 0.361. Again, the decimal jumps twice, so it'd be 36%, but it'd be 36.17, so on. And they told us to round to the nearest whole number. That one tells me just to cut everything off, and it'll just be 0.36 or 36%. So again, let me speak English correctly. You may want to put this in your notes. And by you definitely want to put this in your notes. So percent of change equals the amount of change, or the difference between the two amounts, over the original amount. When you compare the amount of change to the original amount in a ratio, you're finding the percent of change. The percent of change is based on the original amount. If the original quantity is increased, then it is called percent of increase. So it'll be the exact same equation, but there will be a percent of increase. So what we did here with this example is this was 1922, this is 1955. It increased 36%. Therefore, this one is a percent of increase. If the original quantity is decreased, then there is called a percent of decrease. So again, percent of change is the blanket term, but these two, percent of increase is when something changes up, percent of decrease is when it changes down. So here are some examples. The percent of change in the cost of gasoline from 1970 to 2010. Gas cost $1.30 in 1970, cost $2.95 in 2010. We're going to find out the amount of percent that it increased. It is going to be an increase because we see that the second number is bigger. So it is going to be a percentage of increase, or percent of increase. When we subtract, we find the difference is 195. We're going to put that, 165. We're going to put that 165 over 130. When we divide, we're going to simplify it to about $1.27 or 1.27, I should say. Jump that thing twice. It is a jump of 127%. So from 1970 to 2010, gas went up 127% in price. Yusuf bought a DVD recorder for $280. Now it is on sale for $220. Now, the original price was $280, the new price is $220. This went down. It's a decrease, so we're going to find the percent of decrease. Find the percent of change in price. Round to the nearest whole percent if necessary. So again, we're going to find the difference between the two. 280 minus 220 will give me $60. So I'll put 60 over the original price, which was 280, and then divide. This will come up to about 0.21. And remember, we jumped the decimal twice. So the DVD recorder went on sale for about 21% of its original price. The price of the DVD recorder decreased by about 21%. Find the percent of change from 10 yards to 13 yards. Now, this is the original amount. This is the new amount. This is an increase, so we're going to have a percent of increase here. 10 to 13 is a difference of 3. So let me erase this. So again, we would do 13 minus 10, which would give me 3, over the original amount, which is 10. 3 divided by 10 will give me 0.3. 0.3, and I jump the decimal twice, so this is an increase of 30%. And you would write a sentence saying that from 10 to 13 yards is an increase of 30%. Now let me go ahead and erase this whiteboard. And I keep closing the calculator. I'm going to need to keep this open just in case. The price of a radio was $20. It is now on sale for $15. What is the percent of change in the price of a radio? Now this is going to be a decrease because it was originally 20, now it's 15. So it went lower, a decrease. It went lower by $5. I can tell 20 minus 15 is 5. So it will be 5 over the original price, which was 20. 5 divided by 20 will give me 0.25. Decimal needs to jump twice. This is a decrease of 25%. So you could write a sentence like the radio is on sale for 25% off, or the price of the radio went down 25%. And this is our last vocab term for this lesson, percent error. The percent error is a ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. Percent error equals amount of error over actual amount. Finding the percent error is similar to finding the percent of change. Instead of finding the amount of increase or decrease, you will find the amount an estimate is greater or less than the actual amount. Suppose you guess that there are 300 gumballs in a jar, but there are actually 400. So, percent error here would be guess is 300, the actual amount is 400. The difference between the two is 100. So 100 over 400, the percent error was 25%. If I did 100 over 400, I can chop off those zeros and make it 1/4. And we all know 1/4 is 25. 1 divided by 4, give me 0.25. Jump the decimal twice to the right. It gives me 25%. An example. Ahmed wants to practice free throws. He estimates that the distance from the free throw line to the hoop and marks it with a chalk. Ahmed's estimate was 13.5 feet. The actual distance is 15 feet. Find the percent error. So, since the actual distance is 15 feet minus 13.5 that he estimated, there's a 1.5 foot difference. So 1.5 feet is our numerator. our denominator is going to be the actual amount, which is 15 feet. So I'll have 1.5 divided by 15. I have 1.5 here already. Divide it by 15. Gives me 0.1. I jump the decimal twice, so my percent error is 10%. Find the percent error if the estimate is $230 and the actual amount is $245. The difference between the two is 15. 245 minus 230 gives me 15. Now remember, we put the difference as the numerator, and we divide it by the actual price, which is 245. That gives me 0.0612244. Decimal will jump twice to the right, so this will give me 6. The next number is 1, therefore it'll stay at 6. So this is a percent error of about 6%. And that's it for lesson 5. I mean, we can review the signer notes really quickly. I would still highly suggest you put the signer notes in your notebook. Percent of change is a ratio that compares the change in quantity to the original amount. Remember, percent of change is the blanket term. Whether it's an increase or a decrease, you're still finding a percent of change. Percent of increase is when the original amount is increased. Percent of decrease is when the original amount is decreased. More times than not, percent increase is when something grows over time, like speed in a race or gas prices. Percent of decrease is going to talk about things losing their value or like things going on sale. And then we also talked about the percent of error, which is when you try to guesstimate how much something's going to be, or how much you think it is. When you find out the true amount, you find the percent of error by doing the difference over the true amount, dividing and then rounding. So that's it for lesson 5. I've been Mr. P. As always, please make sure to email, message on Teams if you have any questions. Otherwise, I will catch you guys on lesson 6.